Good day. The simplest example of parabolic partial differential equation is heat conduction. Link of this quiz is on the description. Quiz item 1, multiple choice. A metal bar of length 0.08 meter is subjected to a temperature of 95 degrees Celsius on the left end and 31 degrees Celsius on the right end. Find the temperature distribution in the metal bar when time is equal to 20 seconds, from the range time is equal to 0, and time is equal to 40 seconds. Change in location, delta x is equal to 0.02 meter. Change in time is equal to 20 seconds. Density of the metal bar rho is 7600 kg per cubic meter. Specific heat C is 470 joules over kilogram K. Thermal conductivity K is 53 W over meter K. 19 degrees Celsius is the initial temperature of the metal bar. Choices are provided. Please pause the video and try to answer the item. We are asked to find the temperature distribution in the metal bar when time is equal to 20 seconds. For the solution, first we have to get the thermal diffusivity alpha given by the thermal conductivity over density times specific heat. So, thermal diffusivity is equal to 53 over the quantity 7600 kg per cubic meter times 470 is equals to 1.4838 times 10 raised to negative 5 square meter per second. Second, lambda is equals to thermal diffusivity times the quantity change in time over delta x squared is equals to 1.4838 times 10 raised to negative 5 square meter per second times the quantity 20 seconds over 0.02 meter squared. So, lambda is equals to 0.7419. Next, number of time steps is equals to final time minus initial time all over change in time is equals to 40 seconds minus 0 all over 20 seconds. So, number of time steps is equals to 2. We have a diagram showing the node distribution. We have 5 nodes having 0.02 meter distance from each other. Boundary conditions is given by the problem. Temperature at time j and at location 0 is equal to 95 degrees Celsius. Temperature at time j and location 4 is equal to 31 degrees Celsius. This holds true for all j is equal to 0, 1, and 2. Nodes temperatures, except the boundary conditions, are at 19 degrees Celsius when time is equal to 0. Writing this, we have T sub 0 raised to 0 is equal to 95 degrees Celsius. T sub 1 raised to 0 is equal to T sub 2 raised to 0 is equal to T sub 3 raised to 0 is equal to 19 degrees Celsius. T sub 4 raised to 0 is equal to 31 degrees Celsius. Nodes temperatures when time is equal to 20 seconds. We have to set the node number along time j is equal to 0 and node number along the x direction 1 is equal to 1, 2, 3, and 4. T sub 0 raised to 1 is equal to 95 degrees Celsius as stated by the boundary conditions. T sub 1 raised to 1 is equal to T sub 1 raised to 0 plus lambda times the quantity T sub 2 raised to 0 minus 2 times T sub 1 raised to 0 plus T sub 0 raised to 0 is equal to 19 degrees Celsius plus 0.7419 times the quantity 19 degrees Celsius minus 2 times 19 degrees Celsius plus 95 degrees Celsius. So, T sub 1 raised to 1 is equal to 75.4 degrees Celsius. T sub 2 raised to 1 is equal to T sub 2 raised to 0 plus lambda times the quantity T sub 3 raised to 0 minus 2 times T sub 2 raised to 0 plus T sub 1 raised to 0 is equal to 19 degrees Celsius plus 0.7419 times the quantity 19 degrees Celsius minus 2 times 19 degrees Celsius plus 19 degrees Celsius. So, T sub 2 raised to 1 is equal to 19 degrees Celsius. T sub 3 raised to 1 is equal to T sub 3 raised to 0 plus lambda times the quantity T sub 4 raised to 0 minus 2 times T sub 3 raised to 0 plus T sub 2 raised to 0 is equal to 19 degrees Celsius plus 0.7419 times the quantity 31 degrees Celsius minus 2 times 19 degrees Celsius plus 19 degrees Celsius. So, T sub 3 raised to 1 is equal to 27.9 degrees Celsius. Lastly, T sub 4 raised to 1 is equal to 31 degrees Celsius as provided by the boundary conditions. Therefore, the correct answer is letter A.